everyone, my name is Ankit Arora, Assistant Professor, Department of Computer Science and Engineering, Chhattisgarh Swami Vivekanand Technical University, Bhilai. Today's topic is Introduction to Expert System. Before that, let's have a quick recap on last lecture on machine learning. Welcome to this quick recap of the machine learning chapter. In the last session, we discussed into the fundamental concepts of machine learning, its types and its applications. Let's review the key points to reinforce your understanding. What is machine learning? Machine learning is a subset of artificial intelligence that focuses on creating algorithms and models that enable computer to learn and make predictions or decision based on data. It's all about algorithms improving their performance over time through experience. Types of machine learning. There are three types of machine learning: supervised learning, where models are trained on labeled data; unsupervised learning, which deals with unlabeled data and aims to find patterns or groupings; and reinforcement learning, where agents learn by interacting with an environment and receiving rewards or penalties. There's a variety of machine learning algorithm, each suited for different tasks. Examples include linear regression for regression tasks, decision trees for classification, k-means clustering for unsupervised grouping, and deep neural networks for complex pattern recognition. Segment 5: Machine learning applications. Machine learning is transforming industries. It's used in healthcare for disease prediction, finance for fraud detection, e-commerce for personalized recommendations, and even self-driving cars for object recognition and navigation. Segment 6: Ethical considerations. As we embrace machine learning, we must address ethical concerns. These include bias in algorithms, data privacy, and the potential impact on jobs. Striking a balance between innovation and responsibility is crucial. Conclusion. And there you have it, a quick recap of our machine learning chapter. We have covered the basics, types, process, algorithms, applications, and ethical aspects of machine learning. Keep in mind that this field is continually evolving, so stay curious and engaged to keep up with the latest developments. Objectives of today's class: learn the meaning of an expert system, understand the problem domain and knowledge domain, learn the advantages of an expert system, understand the stages in the development of an expert system, examine the general characteristics of an expert system. Now, what is expert system? An expert system is a computer system that emulates or acts in all respects with the decision making capabilities of human expert. Professor Edward Feigenbaum, Stanford University. In other words, we can say that an expert system is an artificial intelligence computer program that emulates the decision making ability of a human expert in a specific field or domain. It achieves this by utilizing a knowledge base containing a collection of information, rules, and heuristics acquired from domain experts, along with an inference engine that processes this knowledge to draw conclusions, make decisions, or solve complex problems within the defined domain. Expert systems are designed to provide expert level insights and recommendation, making them valuable tools for various applications including medical diagnosis, troubleshooting complex system, financial analysis, and more. Now, areas of artificial intelligence. The area includes robotics, developing intelligent robots capable of performing tasks in the physical world, from industrial automation to healthcare assistance and even exploration. Computer vision, enabling machines to interpret and understand visual information from the environment used in facial recognition, object detection, image and video analysis, and even autonomous vehicles. Natural language processing, focusing on the interaction between computers and human language, including tasks like language generation, sentiment analysis, language translation, chatbots, and speech recognition. Machine learning, this is a subset of artificial intelligence. Machine learning involves training algorithms to learn from data and improve their performance over time, encompassing areas like supervised learning, unsupervised learning, and reinforcement learning. Expert system, creating computer programs that emulate the decision making abilities of human expert in specific domains, aiding in problem solving and decision making. Artificial neural networks and deep learning, utilizing neural network with multiple layers to model complex patterns and relationships in data, revolutionizing tasks like image recognition, language processing, and more. Speech, speech technology has evolved from robotic utterances to the art of understanding and generating human-like speech. It's changing how we interact with devices and transforming industries. As we continue to refine these capabilities, let's remember that speech in AI isn't just about technology. It's about making machines more accessible, adaptable, and relatable to us, the human race. Expert system components, knowledge base, obtainable from books, magazines, knowledgeable persons, etc. Inference engine, which draws conclusion from the knowledge base. As shown in the figure, basic functions of expert systems. The basic architecture of an expert system consists of several components that work together to mimic the decision making process of a human expert within a specific domain. The key components of an expert systems architecture include knowledge base. The knowledge base is where all the information, rules, facts, heuristics, and domain specific knowledge are stored. It serves as the system's memory and contains the expertise that the expert system uses to make decisions. Inference engine. The inference engine is the reasoning component of the expert system. It processes the information from the knowledge base using various inference and reasoning techniques to draw conclusions, make inferences, and generate recommendations. User interface. The user interface is the point of interaction between the user and the expert system. It allows user to input queries, provide information, and receive responses in a user friendly manner. User interfaces can range from simple text based system to more complex graphical interfaces. Problem and knowledge domain relationship as shown in the figure. The relationship between the problem domain and the knowledge domain is a fundamental aspect of expert systems. It defines how the expertise, information, and the rules stored in the knowledge domain are applied to solve problems within the problem domain. Let's explore this relationship in more detail. Problem domain. The problem domain is the specific area or field where the expert system is designed to provide solutions, make decisions, or offer recommendations. It represents the real world situation or issues that users seek assistance with. This can range from medical diagnosis and financial analysis to troubleshooting complex machinery. Knowledge domain. The knowledge domain encompasses the expertise, information, rules, facts, heuristics, and domain specific knowledge that the expert system has acquired from human experts. It forms the core repository of knowledge that the system possesses to make decision and solve problem within the problem domain. Advantages of expert system. Expert system offers several advantages across various domains due to their ability to replicate human expertise and decision making. Here are some of the key advantages of expert system. Consistent decision making. Expert system ensure consistent and uniform decision making as they follow predefined rules and logic. This consistency eliminates the variability often seen in human decision making. 24/7 availability. Expert system can operate round the clock without fatigue or breaks, providing instant assistance and solution to users at any time, enhancing efficiency and responsiveness. Scalability. Once developed, expert systems can be easily replicated or scaled to handle a high volume of cases, making them suitable for applications that require handling a large number of tasks or queries. Capture and retention of expert knowledge. Expert systems allow organizations to capture and retain valuable expertise even when experts retire or leave the organization. This prevents knowledge loss and ensures continuity. Quick problem solving. Expert system can rapidly analyze complex situations and provide solutions or recommendations within seconds. This speed is particularly beneficial in critical situations where time is of the essence. Reduce training time. In domains requiring specialized knowledge, expert system can assist less experienced personnel by providing guidance and recommendations, reducing the need of the extensive training. Handling complex data. Expert system can process and analyze vast amount of data, identifying patterns and relation that might be difficult for humans to detect, leading to more accurate and comprehensive insights. Adaptability. Some expert systems incorporate learning mechanisms that allow them to adapt over time based on user feedback and new data. This adaptability improves their accuracy and relevance. Objective decision making. Expert systems make decisions based on logic, rules and data, eliminating personal biases and emotions that affect from human decision making. Risk reduction. In domains where errors can have serious consequences such as healthcare or finance, expert systems help mitigate risks by providing accurate and reliable information. Availability of multiple experts. An expert system can encapsulate the knowledge of multiple experts, enabling it to provide a range of perspectives and insights. Remote accessibility. Expert system can be accessed remotely, allowing users to seek guidance and solutions from anywhere with just an internet connection. Cost savings. Over time, expert system can reduce costs associated with human experts, training and errors, leading to long-term financial benefits. Consolidating domain knowledge. Expert system consolidate and organize domain specific knowledge, making it accessible to a broader audience and enhancing collective expertise. Decision support. Expert system serves as valuable decision support system tools, assisting users in making informed choices and considering various factors before making decisions. These advantages underscore the significant impact that expert systems have on improving efficiency, accuracy and decision making across various industries and domains. Representing the knowledge. The knowledge of an expert system can be represented in a number of ways, including if then rules such as if you are hungry then eat. Knowledge engineering. The process of building an expert system. The knowledge engineer establishes a dialogue with the human expert to elicit knowledge. The knowledge engineer codes the knowledge explicitly in the knowledge base. The expert evaluates the expert system and gives a critique to the knowledge engineer. Development of an expert system. Problem identification. The process begins by identifying a specific problem or task within a domain that requires expert knowledge. Domain knowledge gathering. Domain experts are consulted to gather the required knowledge, rules, facts and heuristics related to the problem. Knowledge engineer interaction. Knowledge engineer facilitate the interaction between the human expert and the development process. They translate the expert's knowledge into a suitable format for expert system. Knowledge representation. The acquired knowledge is organized and structured using appropriate knowledge representation methods such as production rules or semantic networks. Rule based creation. Knowledge engineers create a rule base that consists of rules derived from experts' knowledge. These rules guide the inference engine's decision making. Inference engine implementation. Programmers implement the inference engine which processes rules and makes decision based on user inputs and the knowledge base. User interface development. developers create the user interface that enables users to interact with the expert system, input data and receive recommendations. Testing and validation. The expert system is rigorously tested using sample cases and real world data to ensure its accuracy and reliability. Documentation. Comprehensive documentation is created to explain the system's architecture, components, usage guidelines and reasoning mechanisms. User training. End users and administrators are trained to effectively use the expert system, understand its outputs and provide inputs. Deployment. The expert system is deployed in the target environment, allowing users to access and utilize its capabilities. Maintenance and updates. The expert system is continuously maintained and updated to ensure its relevancy and accuracy over time. Feedback and improvement. User feedback is gathered to identify areas for improvement, potential enhancements and ways to enhance system performance. This flow diagram outlines the sequential steps involved in developing an expert system by harnessing the expertise of human experts, the skills of knowledge engineers and the creation of a knowledge base that drives the system's decision making. The role of AI. An algorithm is an ideal situation guaranteed to yield a solution in a finite amount of time. When an algorithm is not available or is insufficient, we rely on artificial intelligence. Expert system relies on inference. We accept a reasonable solution. Uncertainty. Both human experts and expert system must be able to deal with uncertainty. It is easier to program expert system with shallow knowledge than with deep knowledge. Shallow knowledge based on empirical and heuristic knowledge, deep knowledge based on basic structure, function and behavior of objects. Early expert system. Dendral used in chemical mass spectroscopy to identify chemical constituents. Mycin, medical diagnosis of illness. Depmeter, geological data analysis for oil. Prospector, geological data analysis for minerals. XCON R1, configuring computer systems. The table shows broad classes of expert system. Problems with algorithmic solutions. Conventional computer programs generally solve problems having an algorithmic solutions. Algorithmic language include C, Java and C hash. Classical AI problem include Lisp and Prolog. Considerations for building expert system. Can the problem be solved effectively by conventional programming? Is there a need and a desire for an expert system? Is there at least one human expert who is willing to cooperate? Can the expert explain the knowledge to the knowledge engineer in a way he can understand it? Is the problem solving knowledge mainly heuristic and uncertain? These are some of the considerations which are to be kept in mind while creating an expert system. Now, languages, shells and tools. Expert system are post third generation. Procedural language, example C, focus on techniques to represent data. More modern languages such as Java focus on data abstraction. Expert system languages, example CLIPS, focus on ways to represent knowledge. Elements of an expert system. User interface, mechanism by which user and system communicate. Exploration facility, explains reasoning of expert system to user. Working memory, global database of facts used by rules. Inference engine, makes inferences deciding which rules are satisfied and prioritizing. Agenda, a prioritized list of rules created by the inference engine whose patterns are satisfied by facts or objects in working memory. Knowledge acquisition facility, automatic way for the user to enter knowledge in the system bypassing the explicit coding by knowledge engineer. Knowledge base includes the rules of the expert system. Now, it is time to check your understanding. Which component of an expert system is responsible for controlling the flow of reasoning and decision making processes? It is inference engine. Why? The inference engine controls the flow of reasoning and decision making process in an expert system by applying rules and facts from the knowledge base to the user's query. We will just summarize what we have just learned. Expert system are knowledge based system for solving real world problems. Expert system are not suited for all applications. Future advances in expert system will hinge on the new quantum computers and those with massive computational abilities in conjunction with computers on the internet. Expert systems have found applications in various domains due to their ability to emulate human expertise and make informed decisions. Here are some common applications. Medical diagnosis. Expert systems are used to assist medical professionals in diagnosing diseases and recommending treatment options based on patient symptoms and medical knowledge. Financial analysis. They can help with investment, risk assessment and portfolio management by analyzing financial data and market trends. Customer support. Chatbots and virtual assistants use expert system to provide customer support by answering queries, troubleshooting issues and guiding users through processes. Manufacturing and quality control. Expert system can monitor manufacturing processes, identify defects and suggest adjustment to maintain quality of the product. Troubleshooting and maintenance. They aid technicians in diagnosing and repairing complex machinery and systems such as computer networks or industrial equipment. Agriculture. Expert system assist farmers in crop management, pest control and irrigation scheduling by considering factors like soil conditions and weather. Educational systems. They can personalize learning by adapting content and recommendations based on a student's progress and learning style. Legal and compliance. Expert system help legal professionals with legal research, contract analysis and compliance assessments. Oil and gas exploration. They assist geologists and engineers in analyzing seismic data and well logs to locate oil and gas reserves. Natural language processing. In language translation and sentiment analysis, expert system process and understand human language for translation or sentiment analysis. Space exploration. They aid in the analysis of data from space missions, helping scientists make decisions about mission planning and data interpretation. Environmental management. Expert systems can assess environmental impact and recommend strategies for pollution control and resource management. Diagnostic tools. They are used in various equipment and device diagnostics such as automotive troubleshooting and electronics repair. Game playing. Expert systems have been designed to play complex games like chess and Go, competing with human players. Robotics. In robotics, expert systems help robots make decisions about navigation, object recognition and task planning. human resource. They can assist with personnel, management of tasks including recruitment, performance evaluation and career development. These are just a few examples of the diverse applications of expert systems. Their ability to process and apply domain specific knowledge makes them valuable tools in fields where complex decision making and problem solving are required. Thus, expert systems are computer programs that mimic the decision making abilities of a human expert in a specific domain. The need for expert system arises from several factors. Scalability. In complex fields like medicine, law or engineering, the amount of information to be processed and analyzed can be overwhelming for a human expert. Expert system can handle large volumes of data efficiently. Consistency. Expert systems provide consistent advice or decisions based on established rules and knowledge, reducing the likelihood of errors due to human biases or fatigue. Knowledge retention. Expert system can capture and store the knowledge of experts, ensuring that valuable expertise isn't lost when experts retire or leave an organization. 24/7 availability. They are available round the clock, providing immediate assistance regardless of the time or location, which is often crucial in fields like healthcare. Training and learning. Expert system can be used as training tools for novices, allowing them to learn from systems recommendations and insights. Cost efficiency. While the initial development of expert system can be expensive, they can reduce long-term costs by minimizing errors, improving efficiency and reducing the need for expert consultation. Complex decision making. In domains where decisions involve complex rule-based reasoning, such as diagnosing medical conditions or assessing legal cases, expert systems excel at providing structured logical decisions. Justification for using expert systems typically revolves around the specific benefits they bring to a particular domain or organization. It's essential to weigh the advantages against the costs and complexity of developing and maintaining such systems. Using an expert system can be justified in various situations and domains due to the numerous benefits it offers. Here are some justifications for using expert systems. Knowledge capture and retention. Expert systems are excellent tools for capturing and retaining expert knowledge within an organization. They provide a means to codify and preserve the expertise of subject matter experts, especially in fields where expertise is valuable but experts may retire or move on. Consistency. Expert systems provide consistent and standardized decision making. They can assure that the same rules and criteria are applied uniformly across different cases, thus reducing variability and errors in decision making. (24/7) availability. Expert system can be available 24/7, providing access to expertise at any time. They don't experience fatigue and they can handle inquiries and tasks even outside of regular working hours. Scalability. Expert system can scale to handle a large number of cases or inquiries simultaneously. They can assist multiple users concurrently without a decrease in performance. Speed and efficiency. Expert system can process information and make decisions much faster than humans. This can lead to significant time and cost savings, especially in industries where quick decision making is crucial. Reduced costs. By automating decision making and problem solving processes, expert system can lead to cost reductions. They can replace or augment human experts, reducing labor costs and errors. Consolidating expertise. In complex fields, there may be multiple experts with different specializations. Expert systems can consolidate this expertise ratio into a single system, making it easier to access and utilize collective knowledge. Training and decision support. Expert system can serve as training tools for less experienced personnel. They can also provide decision support, offering recommendations and explanations to assist users in making informed choices. Adaptability. Expert systems can be updated and adapted easily to incorporate new knowledge or changes in rules and regulations. This flexibility allows organization to stay current and compliant. Risk management. In high risk industries such as healthcare and finance, expert system can help mitigate risks by ensuring that decisions are based on best practices and regulations. Handling complexity. Expert systems excel in handling complex and multifaceted problems where there are numerous variables and dependencies. They can process and evaluate complex data quickly and accurately. Scalable expertise. Expert system can provide expertise in specialized areas where it may be challenging or expensive to find human expert, such as rare medical conditions or cutting edge technologies. Data driven decision making. In fields with large amount of data, expert system can analyze data patterns and trends to make data driven decisions, leading to better insights and outcomes. Continuous improvement. Expert system can collect data on their performance and user interactions, allowing organizations to refine and improve their knowledge base and decision making processes over time. In the present lecture, we have learned about the basics of expert system, their basic architecture, applications, usability, and the various domains in which they can provide their inputs and make the tasks and problem solving capacity much more easier than it could ever have been thought. In the next lecture, we will discuss about justification of expert system.